with you. Don't know why this won't open. But I can go to the problem here. It's in the here. So what we're talking about is how to take something that is an exponential or logarithmic data set and linearize it. And I want to show you how this shows you how to do this with your calculator, but I think most of you are using Desmos. So I'd like to show you how to do this in Desmos and also how to notice when you might want to linearize data. So, oops, it even did that for me. That's crazy. Let's go back here a little bit. I'm gonna not have this here. So the first thing I just did was I took this data set, time and hours, and amount of caffeine. So this is my X variable, and this is my Y variable, and I just plugged that in. I needed to change my scale so that I dealt with all of this right. X goes up to 25, so I made it go to 30, and the highest value of Y was 270, so I made it go up to 300. And I can see that this looks like an exponential decay, and that would make sense because your body's clearing that caffeine out of your, so this is time and how much caffeine. So you drank the cup of coffee that had 270 milligrams of caffeine, and this data set is showing what happens is that caffeine leaves. Now, when we see this, we were asked to linearize the data. So can we take this and make it into a linear function? And what we can do is we can just add a second table here. Our X values, we're not changing that, right? We still have the same amount of time. And for our Y, we can use log or ln. Either of these is going to be okay. And I want to use ln of 270. And then I'm going to go ln of 135, ln of 67.5, ln of 33.75, ln of 16.875, and ln of 8.4375. And it looks almost like a straight line, but if we were to change our scale, because we don't need to go up so much, right? If we were just to say, we're going to lose that first graph, but if I go between, say, -10 and 10, now I can see clearly that that is linearized. I have a line. And I didn't know that this was a feature, but you can add regression to any table, which is very nice because now we see our regression. And we just need to remember that this Y is a log, so, or natural log. So let's look back at the answer key, right? We got this same linear equation, but we need to remember that this is not just X and Y, that this was the ln, we took the log of that C value. So we want to make sure in the end that we put it back in the terms of our original equation or our original data set, that we had amount of caffeine and time. And then the last part of this question says, how much is left after 36 hours, right? So we can plug in the time of 36 and we can solve for C, or because we already have this in here, we could add, we want X to equal 36. And we would need to remember that we didn't make it go out that far, so let's go out to 40, right? And now we could find the intersection point, right? At 36 hours, there's 0.61 milligrams of caffeine, and let's just double check. So that's, again, we have to remember we're taking the log of that. So we use that as our value, and we get the amount of caffeine in there. So we just have to remember very carefully that we're using the log of the Y value and making sure we evaluate it in those terms. All right, so this is how you can use Desmos to notice that I need to take, right? If I look at this data set, I notice when I can linearize it, and then I can also work to find the value to which I then evaluate. I hope that is helpful, and if not, we can do some more of these in class.